So let's solve the quiz number 2, one of the options. For example, option number 2. Okay. So we're given a series, the power series. We need to check this for the convergency, right? And we need to find the radius and interval of convergency. So this is given in a form. The sum n goes from 1 to infinity minus 1 in the power of n multiplied to the x squared divided to the n squared, right? Like this. X in the power of n divided to the n squared. So in order to do this, first of all, we need to define an, right? So in our case, an is going to be equal to the x in the power of n divided to the n squared multiplied to the minus 1 in the power of n. And an plus 1, it's going to be, you need to substitute n plus 1 to all the terms, to all the appearances of the n. This is going to be equal to the x in the power of n plus 1 divided to the n plus 1 in the square multiplied to the minus 1 in the power of n plus 1, right? Then we need to find the limit of the ratio an plus 1 divided to the an in the module when n goes to the infinity. This is equal to the limit of, so an plus 1 is going to be x in the power of n plus 1 divided to the n plus 1 in the square, right? Since we're taking everything in the module, we can just skip the minus 1s in the power of n and n plus 1. Multiply to the reciprocal of the an, right? Reciprocal of the an is when we swap the places of the numerator and the denominator. It's going to be equal to the n squared divided to the x n. So when n goes to the infinity. So please note that this x in the power of n plus 1 can be written as x in the power of n multiplied to the x, right? And we can cancel x in the power of n on the numerator and x in the power of n on the denominator. And what we'll have is simply x in the module, right? I took out this x, one x, outside the limit and outside the limit, multiplied to the limit when n goes to the infinity. In the module, n squared divided to the n squared plus tn plus 1, right? So this limit is equal to the 1 when n goes to the infinity. So that is why what is left is simply model of x. So when we check this ratio, if this ratio is less than 1, then the series is convergent, right? So the domain of the convergence of the series is less than 1, and the radius of convergence is equal to the 1, okay? Actually, in order to make this convergency analysis for this power series fully, you need to check the borders of the domain as well, okay? So you need to check this by yourself when n is equal to the 1, and when x is equal to the 1, and when x is equal to the minus 1 separately, okay? So when x is equal to the 1, for series, n goes from 1 to the infinity, minus 1 in the power of n, multiplied to the x in the power of n squared. When we substitute x was 1, it becomes just a summation of minus 1 in the power of n, multiplied to the 1 divided to the n squared, when n goes from 1 to the infinity, and this series is convergent, right? 1 over n squared is convergent, and minus 1 multiplied to the in the power of n multiplied to the 1 over n squared is also convergent, right? So actually the series is absolutely convergent, okay? So when x is equal to the minus 1, the series becomes n from 1 to the infinity minus 1 in the power of n plus 1, right? Multiplied, n. Multiplied to the, again, minus 1 in the power of n, right? Because if you substitute x with the minus 1, it becomes minus 1 in the power of n, right? Divided to n squared. Yes? Okay. So minus 1 in the power of n multiplied to the minus power 1 in the power of n means minus 1 in the power of n plus n, right? This is going to be equal to the summation n goes from 1 to the infinity minus 1 in the power of n plus n divided to the n squared, which is the same as n goes from 1 to the infinity minus 1 in the power of tn, right? So it means that the powers of the minus 1 is going to be always even, right? So minus 1 in the power of tn means no matter which n you choose, the power of the minus 1 is always even, Okay? So if you power up the minus 1 to the even degrees, then you will always have 1, right? So this is going to be equal to the 1 divided to the n squared. But we know that the sum of 1 divided to the n squared is also convergent. Okay? So actually, our domain of convergence is not just x in the module less than 1. It is less or equal to the 1. Okay? So let's go to the second problem. In the second problem, we're given a function cosine of x. We need to expand this in the Taylor series when the center is equal to the pi, right? So we need to expand the cosine of x. So our function is equal to the cosine of x. And we need to write this in terms of the Taylor series. And we know that this is going to be equal to the f of a, right? Plus f prime of a multiplied to the x minus a plus ft prime of a multiplied to the x minus a in the square divided to the t plus f3 prime at the a multiplied to the x minus a and a cube divided to the 6 and so on. It is okay if you found only 3 or 4 terms. Okay? So our function is cosine of x. And our a is equal to pi, right? So in order to evaluate this term, the first coefficient of the series, we need to find f of pi, right? What is the f of pi, which is cosine of pi? Minus 1, right? So in order to find this term, we need to take the derivative of this function. It is going to be minus sine of x. When x is equal to the pi, it is going to be equal to the 0, right? Sine is 0 for every pi, okay? So this term is equal to the 0. This is equal to the minus 1. And in order to find this term, we need to take the second derivative of this function. Second derivative of this function is going to be equal to the minus cosine of x. When we evaluate this when x is equal to the pi, do you understand why we're evaluating this when x is equal to the pi, right? Because here we need to put not ft prime of 0. We need to put ft prime of a, where a is equal to the pi. So this is going to be equal to the plus 1, right? Because cosine of pi is minus 1. And f3 primes of x is going to be equal to the minus or plus sine of x. When x is equal to the pi, it's going to be equal to the 0 again. Okay? So the first 4 terms of the series can be written in this form. So the first term is minus 1 plus 0 multiplied to the x minus pi plus 1 divided to the t multiplied to the x minus pi in the square plus 0 multiplied to the x minus pi in the cube over 6 and so on. So basically we can write it as minus 1 plus x minus pi in the square over t and plus or minus probably. The next term is going to be equal to the minus x minus pi in the power of 4 over 4 factorials and so on. Okay? This is the Taylor series of the cosine of x around center a is equal to the pi. So question number 3, we need to describe in 3D what is the y is equal, what is the equation, what is the graph of the equation, y is equal to the minus 2. Okay? So question number 3, we need to explain what is the graph of this equation. Okay? So yesterday we talked about the graphs and the points in the 3D. We need to figure out an object in this 3-dimensional space so that all the points in the inside this object or on side of this object are going to have the y coordinates to be equal to the minus 2, right? So the y direction is this one, right? If you go in this direction, you're going to have the minus 2 somewhere here. Okay? So all the points on this plane are going to have the y coordinates to be equal to the 2. Okay? So no matter, you can choose any x values for your points and any z values for your points, but you need to just fix the y coordinates of your points. Okay? So all the points on this plane are going to have y coordinates to be equal to the minus 2. So when we write y is equal to the minus 2 in 3D, it means the plane. Okay? So question number 4. We're given a t vectors, u is equal to 0, minus 3, and 4, and v is equal to 1, 2, and minus 1. And we need to find a vector which is equal to the 3u plus tv, right? So yesterday we've learned that if you multiply a constant to the vector, it is going to be a vector again. And if you add the t vectors with the same dimensionality, it is going to be a vector again, right? So when you multiply this 3 to the first vector, 0, minus 3, and 4, it means that you just need to multiply all the components of this vector to the 3, plus t multiplied to the second vector means you need to add all the components of the second vector to the 2, right? So the first one is going to be 0, minus 9, and 12. And the second one is going to be t, 4, and minus 2. So when you add the t vectors, you're going to have again the vector with a 3 tuple, with the 3 components, right? And you need to add the t vectors component-wise. So the first component of the first vector plus the first component of the second vector is going to be t. Second components are going to be minus 5. And the sum of the third components is going to be 10.